Hello, I'm Deniz Oskay. I'm doing Master in Istanbul Technical University in Architectural Design Computing program. Now I'm going to present you our research that is called Measuring Resilience, dealing with the unmeasurable that we have prepared with my thesis advisor Ethem Gürer. To start with the definition of resilience, it's mostly defined as the ability of a system to respond to, adapt and recover from some disruptive event. Our research follows the motto of Galileo, that is, measure what is measurable and make measurable what is not measurable. And in order to do this, we have borrowed some terminologies from measurement science that are representational measurement, pragmatic measurement, and the scales of Stevens. So the term resilience is highly context dependent and its meaning change according to its use. The word firstly appeared in the field of ecology and defined as the ability of ecosystems to absorb and respond to disturbances. Now, when we look at the definition of Merriam-Webster dictionary, resilience is defined as the capability of a strained body to recover its size and shape after deformation caused especially by compressive stress. This definition is more in relation to the definition of material science, and the second definition is an ability to recover from or adjust easily to misfortune or change, and this definition is more in relation to the use of social scientific use of the term resilience. What is common in these definitions is the responsiveness to unexpected changes and disturbances, and the adaptability and the ability to adapt to such changes. So, due to the context-dependent nature of the term resilience, there are some other terms which can be used interchangeably with the word resilience. That the words are rebound, robustness, graceful extensibility, sustained adaptability, or resistance, recovery, and robustness. In order to measure resilience, we need to explore the indicators of it. Since resilience is not a concept that can be found in the physical world and we don't have an instrument that is calibrated to measure resilience, we need to find the indicators of the resilience, and by measuring these indicators we can conclude with the measurement result of the resilience. For example, if we follow the definition of Gunderson and Holling, they define resilience as a system's ability to withstand disturbance while maintaining its functionality. In this definition, the indicator is accepted as the magnitude of disturbance that a system may withstand and still function. But if we follow the definition of PIM, which is the ability of the system to withstand disturbance, the indicator in this case is then the rate at which the system can return to equilibrium following the disturbance. We can conclude that the definition of the resilience also defines how the measurement procedure will be performed. So, black box measurement. Miyake introduces the phenomenon of black box measurement, which appears when attempting to measure features that are not directly accessible but can be measured by revealing the accessible parts of a system, which is quite similar to our case of measuring the resilience. So, we first need operational use of the definition, and we can define accessible parts in the definition of Miyake as our indicators. So, according to Bridgman, measurement is what the measurement process catches. So, and as a result, the questions define what is being measured themselves. For example, IQ can also be defined as what IQ tests measure, and this is quite similar to the case of resilience. And on the other hand, the measurement result of resilience cannot be evaluated according to its truth or falsity, since in the real world there is not a correspondence if we can check if the result was correct or not, but it can rather be evaluated according to its suitability for a certain context. So, measurement science is defined by international vocabulary of metrology as the process of experimentally obtaining one or more quantity values that can reasonably be attributed to a quantity. And in this one and in more definitions, mostly measurement is equated to the quantification process. Scales of Stevens suggested a categorization system to overcome the limitations of the problem of measurability, and offered 4 types of scale that are ratio, interval, ordinal, and nominal, which is more in detail in our paper. Representational measurement is the homomorphic mapping of a certain empirical relational system onto some numerical system. So in the physical world there must be something represented, and by representing this physical world and their empirical relations onto a numerical system, the representational measurement can be performed. Pragmatic measurement is quite similar to the definition of Bridgman. So one constructs the measurement procedure and also what to measure. So this is called the pragmatic measurement, and the integrated measurement is the use of both representational and pragmatic measurement. So our framework considers two indicators in order to measure resilience. The first is recovery time and level of recovery, and the second one is vulnerability and adaptive capacity. Pym points out that resilience of a system indicates how fast the variables return towards the equilibrium following perturbation. So if we follow the definition of Pym, recovery time is equal to the resilience. So we need the characterization of which points on a time scale are accepted as the start and end point, and when will the system be considered as recovered. So when we examine these figures, we can see different situations, and according to our definitions for these two questions, the calculations can be done as following, as you can see in the screen for the three alternative cases. Vulnerability and adaptive capacity. The question of vulnerable to what is as important as vulnerability of what, since a system may be resilient to a specific kind of disruptive event, but not to any other. In this case, there appear other circumstances needed to be examined, such as the ability to avoid disruptive events, the ability to avoid the impacts of the disruptive event from worsening, or the ability to recover from a disruptive event that has already occurred. While the first one can be considered on a nominal scale, the second and third one can be considered on an ordinal scale. And these figures shows the vulnerability and adaptive capacity, and according to the definition, the operational definition and purpose, the calculations can be done also as following. So in conclusion, it's seen that resilience is a concept that constructs its measurement procedure by depending on how it's defined for its operational purpose. This situation necessitates a clear characterization of the vocabulary. Depending on the literature review, it's concluded that there has been a great amount of research that attempts to create a common language in resilience terminology. This situation demonstrates the necessity of the creation of a common language in the research field of resilience. Then, based on the literature review, the paper stressed the importance of having both well-defined quantitative and qualitative indicators to measure resilience. And lastly, for the further research, since this study is the first attempt to construct a bridge between measurement science and resilience engineering, and it's developed theoretically, it necessitates case studies in order to examine its applicability in the real world situations, and also it can be offered to use the terminology of measurement science, such as derived and fundamental measurement, uncertainty, uniqueness problem, theory of error, validation, calibration, and etc. And by doing so, the potential of measurement science in resilience engineering can be revealed. And these are our references. Thank you so much.